Dear student, today we solve the trigonometrical integration. The main important, very important question is. So the question number 1 is I integral is dx divided by cos alpha and plus cos x. Yes, I have messed up teaching maths to different board classes and UGC classes since 20 years. And this question dx divided by cos alpha plus cos x, where the variable is x but alpha is constant. So the integral has pattern dx divided by, yes, this question are related to this pattern, and according to this pattern I explained in previous video that we use the half angle form of cos x in term of tan x by 2. So I write the value of cos x is equal to 1 minus tan square x by 2 divided by 1 plus tan square x by 2. So we solve this question. Dx divided by cos alpha plus 1 minus tan square x by 2 yes, the value of cos x in term of tan x by 2 is 1 minus tan square x by 2 divided by 1 plus tan square x by 2. And according these substitutions, we can solve by the substitutions method easily, because the 1 plus tan square is equal to sec square x by 2. 1 plus tan square, yes. Then we write here the I integral is sec square x by 2 dx divided by cos alpha multiplied by 1 plus tan square x by 2 and plus 1 minus tan square. Yes, after taking LCM, the integral is written in this form. The 1 plus tan square shift in numerator and write here sec square x by 2 and the value cos alpha, where alpha is constant and x is a variable. So 1 plus tan square x by 2 and plus 1 minus tan square x by 2 as same. And now the I integral is sec square x by 2 dx divided by cos alpha multiplied by 1 is cos alpha and plus 1. So write here cos alpha plus 1, cos alpha multiplied by tan square x by 2 and negative tan square x by 2. So write the value plus cos alpha minus 1 and multiply by tan square x by 2. Now we change this term using the half angle, because I write here cos alpha is equal to 2 cos square alpha by 2 minus 1, so that this one cancel by this negative one, and this cos alpha 1 minus 2 sin square alpha by 2 right in this bracket. So our integral is equal to integration of sec square x by 2 dx divided by, here the value of cos alpha is equal to 2 cos square alpha by 2 and negative 1 cancel by this positive 1. So write here 2 cos square alpha by 2 and plus, write the value of cos alpha here 1 minus 2 sin square alpha by 2, then this one cancel by this one and here the sign is negative 2 sin square alpha by 2 and multiply is tan square x by 2 and 2 is common and yes, we take the common 2 sin square alpha by 2, the I integral is equal to sec square x by 2 dx divided by 1 upon 2 sin square alpha by 2. Yes, this 2 sin square alpha by 2 is common and this term cos square alpha by 2 divided by the common term sin square alpha by 2 is cot square alpha by 2 and here is negative tan square x by 2. So the function here, this was tan x by 2 is our variable term and this one is constant written in as a square. So the I integral is equal to 1 upon 2 sin square alpha by 2 and here we let the tan x by 2 as a t variable. So I write here tan x by 2 is t and half of sec square x by 2 dx is dt. Yes, tan x by 2 is t and after differentiating half of sec square x by 2 dx is equal to dt and these 2 and this sec square and dx change in dt divided by this term is cot square alpha by 2 minus t square. So use the fundamental formula of this integral. Yes, we know that the integral of dx divided by a square minus x square is 1 upon 2a log of a minus x divided by a plus x. So where a value is cot alpha by 2 and the I integral is sin square 1 upon sin square alpha by 2 and multiply by 1 upon 2 times of a value is cot alpha by 2 and log of cot alpha by 2 minus value of t is tan x by 2 divided by cot alpha by 2 plus tan x by 2 and constant is c. Yes, then we write cot theta is equal to cos upon sin. So 1 upon 2 sin alpha by 2 multiplied by cos alpha by 2 and log of cot alpha by 2 minus tan x by 2 . and integral constant is c. Yes, 2 sin alpha by 2 multiplied by cos alpha by 2 is by the formula of the 2 theta of the sin x. So the final answer is I integral is equal to 1 upon sin alpha log of cot alpha by 2 minus tan x by 2 divided by and plus integral constant is c. So this is very important question, and the question number 2 is dx integral of dx divided by root sin cube x sin of x plus alpha. So we solve the question number 2 is yes, then I integral is integral of dx divided by root of sin cube x and sin of x plus alpha. Yes, in this integral we multiply and divide this term by sin x. So write here sin x and divide by sin x. This sin cube x and sin x is sin to the power 4x. So we take this is dx divided by root of sin 4 is sin square x. So write here sin square x and in under sin x plus alpha is equal to sin x cos alpha plus cos x and sin alpha divided by sin x. Yes, here 1 upon sin square is equal to cos x square x dx, and in denominator our term is this sin x cancelled by this one. So write here cos alpha and plus cos x, and cos divided by sin is cot x and multiply with sin alpha. And here we can easily use the substitutions method, because cos alpha and sin alpha both are constant term, but cot x is a variable and derivative of cot x is cos x square. So we can assume that this complete term as t or t square. So the integral is let cos alpha plus cot x sin alpha plus sin alpha multiplied by cot x is equal to t square, and after differentiating derivative of cos alpha, because alpha is constant and derivative of cos alpha is 0, and here negative sin alpha multiplied by cos x square x dx is equal to 2t dt. And so the I integral is equal to integral of this cos x square x dx is equal to 2t divided by 2 times of t dt and divided by negative sin alpha, and this term is t square, and here root, so t square root is t then write here t and both are cancelled. Then we have integral of 1 dt 2 cosec alpha, and integral of 1 is t plus indefinite constant is c, and at last we put the value of t is root of cos alpha plus sin alpha multiplied by cot x. So our solution is minus 2 cosec alpha and root of cos alpha plus sin alpha and multiply with cot x plus indefinite constant is c. So both very important questions are solved by this easy technique. Okay, thank you for watching this video.